I've got a nice short lesson for you today. We're going to carry on working with standard form. Last lesson we saw how standard form was a particular way of writing a relation. It was ax plus by plus c equals 0. It just gives us another way of looking at a linear relation instead of always having slope y-intercept form. We saw how we could switch back and forth between slope y-intercept form and standard form. All I want to look at today is how we can graph things in standard form without having to switch it back to slope y-intercept form. All right, so, and we already know how to do this. In fact, we could use the x and y intercepts. As you can see, I've already written that in here. So we've learned how to use x and y intercepts before. Remember this idea. Let's just go down to the grid for a second here. Y, x. If I want to get an x-intercept, that is a point that's anywhere on this dark line that I just highlighted, right? It could be here, it could be here, it could be here, it could be here. What do we know that's the same about all of them? They all have 0 for their y-coordinate. Look at those 4 points I just randomly drew on there. Imagine if I asked you what ordered pair represents them. Well, that first one would look to on the far left, looks like it would be about negative 4.60. And this one here looks like it would be about negative 1.30. And this one looks like it would be about 2.40. And this one looks like it might be 5.20. I'm just estimating. But what's the same for all of them is they all have the same y-intercept, don't they? So when I want to get an x-intercept, all I do is let y equal 0. And what happens then is I have 8x plus 4 times 0 equals, not equals, plus 12 equals 0. So 8x plus 12 equals 0. Solve that equation. 8x equals negative 12. Divide both sides by 8. I like to use a different color just for that step so you can see it's a separate step. X equals negative 12 over 8, which I know that you would never leave as a unreduced fraction. That reduces to negative 3 over 2, or for graphing purposes, negative 1.5 would be even more useful. When we're graphing it, decimals can be more useful than improper fractions. So that's my x-intercept. I'll come back to that in a second, because I also need to get the y-intercept, right? That's just where it crosses the y-axis. Well, there's the y-axis. What do we know about all points on the y-axis? We know they all have the same x-coordinate, which is 0. For example, this one might be 0 and 4.5. And this one might be 0 and 1.5. And this one might be 0 and negative 2.5. Doesn't matter, but they all have the same x-coordinate because they're on the y-axis. Okay, so if we want to get a y-intercept, we're going to let x equal 0. And when we do that, got 8 times 0, 4y, okay. 8 times 0 plus 4y plus 12, it was plus, wasn't it? Plus 12, yes, equals 0. So 8 times 0 just is 0, goes away. And so then if I rearrange and isolate y, what I get is positive 3. All right, so now I've got my x-intercept, I've got my y-intercept, and remember these are ordered pairs. So my x-intercept is actually, if I go back to this, is negative 1.5 on the x-axis. So that'd be about here. Again, if I just assume my scale is going up or down by 1s, there's negative 1.5. I could think of it as an ordered pair. It's just that it would be negative 1.5 and 0. because we let the y equal 0. Same for the y-intercept. It's going to be at 3 on the y-axis, which would be the same as 0, 3. Notice how the 0 goes in the x spot this time. And there's 2 points. I can draw a line between them. Let's see. I guess if I start about here, hopefully I'll... Nope, I missed. Let's try again. All right, down 3 over 1.5, down 3. Let's try starting here. I always have to pick the right point to start off on the edge so that I can then hit both the dots I've got on there. There we go, I hit them that time. All right, there's my graph using the x and y intercepts. Again, I filled in all the grid. That's important. I didn't make it just a short little nubbin of a line. All right, so x and y intercepts, good way to do it. Let's try it with this one. And again, those are the steps, but we don't have to spend as much time on them as I do when I'm explaining them. To get the x-intercept, if I let y equal 0, well, if we let y equal 0, we know that this term is just going to go away, right? So all I'm left with is x plus 6 equals 0. So I could go right to that without having to write in -3 times 0, and I get x equals -6. There's my x-intercept. Pretty quick. If I want to get my y-intercept, I'm going to let x equal 0. And again, that just makes this term go away here. Drawing an x over an x isn't very helpful, is it? Let's just scribble it out. Okay, that term's gone away. Now I'm left with -3y plus 6 equals 0. And again, super quick to solve. -3y equals -6. I do have to divide in this case. And I though quickly find out that y equals +2. All right, let's do this one in red for a different color. So x-intercept, -6. That's out here if I counted properly. Y-intercept, +2. That's here if I counted properly. Let's try again. Okay, not too bad. Just glancing over this, I see that I made a mistake though. Pardon me. For some reason, going back to the first question, it occurs to me, and I hope this didn't confuse you for too long, it occurs to me that I divided by -4. So here, I divided by -4. Don't know why I divided by -4, just one of those careless mistakes you make. I guess it's because I saw the negative in front of the 12, but this is a +4 I'm dividing by. So that means that this should have been a -3, and that means that my graph is wrong here. Apologies, everybody. So going back, my x-intercept was fine. My y-intercept should have been a -3, and that obviously changes the way my graph's going to go. I'm only connecting 2 dots, and these are the 2. So it looks more like this. So that's a big difference. Again, I always like to take my mistakes and turn them into teaching moments. So the point that I can use this one for is to show you that one careless little slip can make a really big difference on how your graph looks, right? Originally I had it going up to the right, now it's going down to the right. It's going exactly the opposite direction just because of one momentary lapse. So be careful, and we're still going to make mistakes. I still make mistakes, but go back, take your time, check things over like I did, and most of the time you'll catch them if you're careful.